Progress. Progress.
Uh-huh. This one a beach?
Yep.
All right. All right, Pop. Number 2. Got it, show. All right. No. All right. All right, Pop. Yeah. All right.
What do you want? Just to know.
Just,
I'm on video, just to put it out there.
oh man, did they see that?
How would you feel if they did?
I wouldn't mind. All right.
First, are there any questions or concerns?
I think we had a few of us had an issue with the one exercise lab.
What was it? I know there was a question that was odd. What was there something else?
It was on question 11, I think, where you had to label the
And
region.
it was switched around and it just skip, you guys, when you run into those kind of questions, just skip them.
Okay.
It,
I,
it wouldn't take the region. So it was the
I-
right and left lumbar, and then we
Mhm.
tried like 3 other different labelings that maybe would have worked, and it didn't
Yeah,
accept any of
Just
them.
skip them.
Okay.
Just skip them because I'm gonna round up your scores. And let me just give you an idea. Give me one moment here. I'm not gonna share my screen just for 1 second. I know occasionally Wiley will give you a weird way to answer it and just skip them. It's someone, I think it was Marissa, she sent me a picture of it.
Mhm.
And yeah, I mean, what she had was correct and it was telling her it was incorrect. I'm just gonna round up your grade. And none of them, I don't think, I'm trying to think if there were any that were worth a whole point. Bear with me just for a second here. So for example, Justin, I know you're here because I just saw you were just talking. Give me 1 second here. So Justin, it says that what on the first lab exercise 1, 1 and 2, that the first part, you got 7 out of 7. On the second one, it was 2.96 out of 3. I'm gonna round it up to a 3. I haven't done it yet, but realize that's what I'm gonna do every time. So
Okay.
when something like that happens, just skip it. If it ends up having, it usually doesn't happen on a lot of questions, but when it happens, just skip it. And if it ends up bringing you down a whole point, which I haven't seen it do that yet, we can talk about that when it happens. Does that make sense? Is that clear? Since I can't see any faces right now.
Are we supposed to be doing a worksheet?
No, you're just doing those lab exercises. You're not gonna, there's a few things when we submit a case study. Anyone having issues with hearing? Not so far, Samantha. What you might want to do is try coming out, leaving the meeting and then coming back in. What was I going to say? When you do case studies, you guys, let me explain that. So someone just asked that question about worksheets. When we have, the worksheets you just saw, bear with me. I think I know what you're referring to. I'm going to share my screen with you. Be patient with me. Let me explain for a moment what you're looking at. Oh, shoot, don't see that. It was not what you were supposed to see. Not what you're supposed to see. Let's see here. Close this out. We're going to go back into it. So if you look, and before we get started, I need to explain something, because if you miss it, I need you to let me know. I have to take attendance tonight. I may take attendance randomly and not tell you, because I want to see if people are actually showing up.
Hey, Kara, you're not muted. Can you mute your mic?
Oh, sorry.
But I have to take attendance tonight for hack, which means that it has to record whether you're here or not, because if you are on financial aid, if you are not here tonight, it will drop your financial aid. If you're not attending classes and you're getting financial aid, that it will drop you from classes. So we will take a break about halfway through the night, and I will take attendance there. What someone asked about the worksheets. Let me explain what those are. For every chapter, and of course I'm going to the wrong class. For every chapter, I give you what I refer to as a study guide. And if you think of your typical study guides that your other professors or your high school professors have given you, they're usually 1 page long, and they give you a series of words or concepts, right? That sound about right? Typically 1 page long and a series of words or concepts. I think a lot of those are very misleading, because by me, let me give you a specific term: negative feedback loops. We will talk tonight about what a negative feedback loop is. But am I asking you to be able to define it? Am I asking you to give examples of it? What am I asking when I tell you you need to know negative feedback loops? It can be a lot of things. We're going to talk tonight about how all physiology and is positive and negative feedback loops. So instead of doing that, I give you a worksheet that's essentially going to cover everything, and it's got a series of questions or definite things to define. And I will tell you, it's exceptionally long, and it gets longer. First off, like I said last week, anatomy and physiology, there is a lot to learn. There's a lot to know. You can use this to study. And what I would do is I would look it over. And as we're talking, pinpoint certain ones, look it over before class. They're all posted for all of the chapters, except couldn't find the one for chapter 11, which is the last chapter. But they are posted for every chapter. And some of them are really long. I'll bet you if you took all these and took out all the spaces, it would probably slim down to being 1 to 2 pages. So it looks really long because I've also put spaces in there. You can use it or you don't have to use it. I was just talking with my students in 122, which I have this semester, and a handful, probably about a fourth of the class to a third of the class are students that had me last semester. And I asked them if they used this worksheet. They all told me they started and then they stopped. And they started using it initially, but then they realized that they could study the PowerPoints a lot easier for the answers to the questions. And that's what they used. You can decide whether you want to use it or not. But it's here for you to use if you want to. If I were you, I would take each chapter quiz and I would take it the 2 attempts you have. It doesn't matter if you take it once or twice, your highest score is going to be the one recorded. Because a lot of those questions, I take them from a question bank that McGraw-Hill gives me. And I give it a pool of questions and I say, randomly select this many from this pool. And a lot of the exams that I put on, a lot of the questions that I put on those chapter quizzes are also this, many of them are the same as what I put on the exam. So if you want a really good idea of what you know and what you don't know, when you do that chapter quiz, think about what you're doing. Think about it when you're taking it. If you're not sure about something, make a note off to the side. And then take it again and see what you think then. Because some of the questions, if you have a really good memory, you can remember from the quiz, when you take the exam, you might find that some of the questions are the same. That's what I would do. I would use this as maybe a guide, but I would use the PowerPoints more and the homework you're given more to study. So you know you're not going to turn this in. This is essentially a study guide to you. I'm not going to give you the answers for it because we cover all of this in the PowerPoints. All of the material here will be covered in the PowerPoint. And if I miss something, let's say that 99% of it will be covered in the PowerPoint. I can't cover the whole entire chapter. If you look at the chapters in your book, some of them are 50 pages long. you can read the book. I'm covering the major parts. What else was I gonna say? Oh, so I will tell you that as a professor, I'm always learning. I'm always learning. I'm always trying to improve what's going on from semester to semester. And I think I told you, bear with me here because I'm going to click on the syllabus. I told you that I was going to put the the lab quests were going to be on Wiley. Do you remember me saying that they'd be on Wiley? Well, I asked these students who had me last semester, I said, because I gave them the same idea as I put here with you in the syllabus about whether or not I should put those lab questions, should I design them using Wiley or should I design them using McGraw-Hill Connect? And they told me to use McGraw-Hill Connect. I'm going to use McGraw-Hill Connect for you too. And the reason is because first off, the due dates are on, if you go to that content page, the due dates are on, are posted. And even though the manual is not, we don't have a lab manual for McGraw-Hill Connect. And the Wiley one is better. Wiley is better for them. Overall, Wiley is not what people like. If you have a choice preference, by the end of the semester, you're going to realize you like McGraw-Hill Connect a lot more. So I'm going to use McGraw-Hill Connect. If you struggle with that, do me a favor, put it in the evaluation at the end of the semester. That's not, you didn't like that. But right now I'm going to do that because I think overall it's easier and it'll be easier for you. Other questions, someone asked, will you ever turn in worksheet stuff? You will. If you remember, there's going to be 3 case studies. You will submit those online. We won't start them. We don't really start. We go through a lot of basics right now over the next first month to month and a half. And we don't really get into a lot of general specific physiology until we get into chapter 7. And chapter 7 is about bone. That is when you will get your first case study. So I don't want to spend a lot of time talking about case studies right now because you haven't been assigned one yet. When you're assigned one, I will go through it. What you're going to do is you're going to submit it in the Dropbox right here. And you'll have a folder there in the Dropbox. When you submit those, they need to be submitted as either a Word, a PDF, or a JPEG document. I say no other work will be accepted. No other work in any other format will be accepted. And the main reason I won't accept it is because I can't open a lot of it. If you send it to me as a Google Doc, I found that I actually have to pay to open those things. I have to pay Google Docs something to open those things. And I am an adjunct professor. That is not money that I have right now to be able to pay to open up someone's homework. So do not send them to me as a Google Doc. If you cannot submit them as a Word, a PDF, or a JPEG, talk to me. And we'll figure out something else. Other questions?
Yeah, I have a question. Can you please show us again how you got to the worksheet? For whatever reason, I
If
was
you-
not able to get in there.
If you go to content,
Yeah, that's where I'm at. Mhm.
and for every chapter, the worksheet for chapter 1, right underneath the PowerPoint.
So I'm on chapter 18, the blood one. So are you saying
You know what, you were Gina, you're looking under, you're in biology 122.
Oh, yes, I was.
Are you registered for both courses now?
Yeah, yep, I am.
Okay, go to 121. Because
Okay.
if you remember, do you remember me when I talked about this in 122? And I asked those students who had me last
Yes.
semester, and
Yes,
they said they didn't use those.
yes, they did.
That's why I'm putting them here, but I'm telling you that that's not the best way to study.
Okay. So go to chapter 1 and then worksheet for chapters. Okay, I see it now.
Okay. Okay.
Okay. Thank you,
I'm-
sorry.
Well, you kind of clued me in when you said chapter 18.
I'm not able to open the worksheet.
Why? What's going on?
I don't know.
Do you have, what is it telling you when you try to click on it?
Let me try again. Let me open it. It says unexpected server response. Yeah,
What kind of computer are you using?
from
What?
Google Chrome, and this is the first.
Are you using a laptop? Are you using?
Yes, laptop.
Yeah, mine actually says the same thing.
And this is the first problem that I have on this computer.
Is
because I
it-
can everything else? I mean, I can share my screen if you want. so
Well,
you can-
you can try, but it's a computer issue, people. I can't solve that. How many of you, let me ask first, how many, is there someone who can open it?
I can open it, Lauren.
Lauren
can
can
open
open
it.
it.
I can also open it. This is Elizabeth Lorman.
Okay.
What's the error that's coming up for the people that can't?
Unexpected server response.
Did you try exiting and then just reopening it again?
I already tried twice, and this is the third time.
One thing you may have to do is you may have to contact Hacks IT Tech. Because you do have one thing that you may not.
Mine actually under or just above where it says the error, it says view text. If you click on that, then it pops up.
Or if you hit download, it opens
Yeah.
in Word.
Let me try.
Yeah, so now I can see it.
Let me see.
Is it because it might be that there's a pop-up blocker? I don't know what it will be. Sometimes if you have a pop-up blocker, I am not that great with computers. I'm lucky I know how to use my phone. I
had to download it, so now I can see it.
Okay. I have like the Hack IT Tech line on my contacts list. I have the Wiley IT Tech line on my contacts list. I have McGraw-Hill IT Tech line on my contacts list because I'm lucky I know my own computer. And if there's something going on with your computer, I can't solve it. I can tell you what it probably is that it's most likely a pop-up blocker. but I can't tell you how to get rid of it. But if you call like the Hack IT Tech line, and they're open, I think 24 hours a day. They know how to solve that kind of stuff. Wiley, I know their student line is not that great, but McGraw-Hill Connect, they know how to solve those issues. I am just not, the one thing I'm gonna have to tell you, if you ever email me and tell me that something isn't working, I will tell you to call them. Other questions?
Could you,
Go.
sorry,
I was
I was just gonna ask Mary if, or Professor Kessel,
Yeah.
like it shows that I already, check marked off both lab exercises, but I'm pretty sure I didn't actually do the second one. I think sometimes when you go in, I don't think it like moves from like thing to thing super easily, and it looks like I've done it, but now that you're talking about it more, I'm pretty sure I didn't do the second.
Let me look just for a second. Let me look. I'll tell you.
mine checked them off just when I went in there to view it.
One thing that I will tell you is that sometimes there's a submit button on those Wiley exercises.
Okay.
So it says that you did one, you did the first part, but not the second part.
Okay. All right.
If
I
you,
think I went back to try to figure it out, and then I don't know.
bear with me, wait, just give me 1 second here. Because I know that sometimes it will not transfer your grades over, and technology is great up until it doesn't work. So give me 1 second. I just want to look at something. So yeah, it doesn't show that you did it. One thing that I can check is it will show me, I can go to another site, I can go into Wiley, and it will show me whether or not you did it. It doesn't show that you did it.
Okay.
I'm gonna ask, let's do this really quickly. 1 second here. Christina, can you share your screen? Give me 1 second.
Sure.
Let me let you do it just a sec.
Okay.
Now do it.
All right.
When you're ready.
Okay. Let's see. Here we go. All right. Let's see. Yeah, here.
So click on that one really quick. And open it up. Start assignment.
Okay, so if it was finished, would it have said like completed or something?
Yep, and why don't, bear with me here just for a second longer here. Go click start assignment.
Okay.
You have an unlimited amount of things.
Okay, okay. I think that's one reason why I get nervous is because, I mean, I know you said that some things we have unlimited and some things we only have 2 attempts.
If it's a quiz, an exam, or a lab quest, you only have 2 attempts. Because those are essentially exams or quizzes. For everything else, it's unlimited.
See, I feel like I started the quiz accidentally, like when I was doing my reading, because they're both kind of like the reading and the questions at the same time. And so I don't know.
I think that was a smart book.
The smart book, okay, is that
And that's
different?
unlimited. No, that's unlimited.
Okay, and are we supposed to answer those questions in the smart
Yes.
book reading?
Yes.
Okay, I don't think that was very clear, so I was like
It-
nervous.
You know what?
to-
There's no way for me to report whether or not you read. You understand what I'm saying?
Right,
can't-
well,
and
I'm actually
so-
reading from the paper book because I do better than the digital. I'm like
I
old school.
understand that. I understand that, but it's the only way for me to grade that you actually did it is for it to ask you questions.
So what's the best way then for for me to do it? Like, are you supposed to like read a certain point, answer the questions, or read the whole
Why don't
chapter and then
Do
answer?
me a favor, close out of this and go into the first smart work assignment.
Okay.
And I will tell you one thing that you'll learn with smart book assignments is they cater to you and they change their questions based on how you answer.
Okay.
But click on that first smart book
This
assignment.
one?
Mhm.
Okay.
Click launch.
Is that the first one for us to do?
Say it again.
Is that the first one for us
Yep.
to do?
Yes, this is the first one. So click start begin. Now right now, you can do either one. What I would do first is just continue into the questions here.
Okay.
And so a blank oath is a code of ethics for physicians. I
Correct.
think it's the Hippocratic Oath. So click that and continue.
Whoa, whoa.
Oh,
Nope,
wait,
didn't mean to do that.
go back.
Okay.
Go back.
2 questions.
2 questions. So now it's asking you, what's your confidence here? Is that medium, high, or low? Okay. So it's scroll down. I don't, okay, correct. Go
Okay.
to the next question.
All right.
The study of normal tissues or groups of cells and their surrounding materials is called what?
Oh gosh.
If you're not sure about, let me give you
It's
the
like
answer.
gangly. I
No,
think it's ganglion. No.
let me give it to you for this moment. Histology, H.
Oh, that's the study. Yes,
Yep.
yes.
Okay, Y. And now is your confidence? How's your confidence?
Well, since you gave me the answer, it's pretty high.
All right, go with high then. Okay, go to the next question. Who was the famous Jewish physician who served in the court of Sulfan's lab? I would.
Either A or C.
I don't honestly. It's someone in your book. Why don't we read about
the last one? It's the last one.
Okay, then click that if you think it's that one.
No.
Okay.
Did I get it correct?
No.
Got it correct.
Go to the next one. Go to the next one.
All right.
A physician who is listening to your heartbeat is utilizing what kind of diagnostic procedure?
One.
And then what's your confidence? Okay, so this is essentially how it works. If you answer it incorrectly, it's going to ask you if you want to read about it.
Okay. I think I just got confused and I thought that this was potentially part of the quiz or there was a limited amount of attempts. And so I started it and then I'm like, shoot, I probably should read more before I answer more questions.
What I would do if I were you is I would just start it. And you have the book right there.
Yeah.
And so you can look through the book for the answer.
Okay. So basically answering the questions is how you're gonna grade us, like not if
I
we
don't,
quote unquote do the reading in
right,
the online book. So if I do the reading in the paper book, that doesn't really matter. It's just answering the questions.
right.
The
Paisley,
criteria.
come here, come here.
Okay,
Yeah, I'm sorry, get my teaching assistant, just a second.
it's okay. I
Um,
think I just, you know, am trying to make sure I'm like doing all the quizzes and whatever. And so I just kind of stopped doing them and just read all weekend because I was like, well, I don't want to like mess up my number of attempts. So thank you.
You're welcome, and I understand. I understand. All right, so I'm gonna have you stop sharing. Are there other questions? Can you walk through where to find the lab exercise again? You know what, Christine, will you show your screen one more time? Because what you guys see on your screen,
Sure.
and what I see on my screen are very different sometimes. Can you go back, go to Hack EDU portal or either one of those? Now go to,
or my hat.
go to table of contents right here.
Okay.
And then scroll down, scroll down, scroll down, go to Wiley lab exercises.
Okay.
First one right there.
Oh, I'm sorry.
And then scroll up just a little bit. Here, this is where the 2 lab exercises are for this week or for last week. If you click on, do me a favor, I'll give you that first one, Christine, if you'll click on that lab exercises 1 and 2B.
Okay.
And click open the assignment. Then click start assignment. So here, click, hold and click.
Okay.
So medial is that, click on that one and drag it over to the top row, middle area, right there. Yep. And here's, wait, let me make sure. Superior is going to go in the second option, second row, or scroll down, see where that box where you've got a partially overlapping, put it in there.
This one?
Yep. Inferior is going to go in the bottom one down there.
This one.
And then lateral, the 2 laterals are going to go on either side of the medial. And then the proximal and the distal, the shoulder, the square by the shoulder is going to be proximal. And distal is going to be in the bottom. Now, scroll down and click submit answer. So your answer is correct. Now, bear with me here. Scroll down here.
Okay.
I want to see something. Okay, scroll back up again.
Okay.
Please. Go to the next question. Just for kicks right now. I thought, I was told that there was a button that you could click to submit something. I don't see it.
Yeah, almost. Let's see.
Click, do me a favor now, click that back arrow right there. Over in the top left corner. That says lab exercises. Yep, that one right there. Okay, so it gives you credit for that. and scroll down really quick. Scroll all the way down. Okay, I don't see a submit button there at all,
Sorry.
but that's fine. I was told there was one and I don't see one there. But that's,
It
so
logs it as you go along.
say it again.
It logs it as you go along, and then once you get to the very last one, it just automatically submits it. At least from what I remember from doing it today.
Okay, so if you like have to stop in the middle of it, you don't lose what you've already answered.
No, you
Okay.
shouldn't. If that happens, that's when we call Wiley.
Okay.
So you can start these exercises, and if you're into it and you just have to take a break, you walk away. When you come back, you can go back in and
Huh?
continue where you were. Okay, good to know.
Is that due tomorrow or today?
It's due tomorrow at midnight.
Okay, that's what I thought. Okay.
Okay, now Christine, let's have you stop sharing.
Okay. All right. Thanks.
You're welcome. What was I going to show you? Just give me 2 seconds. I think I know I had something. Maybe I didn't. Any other questions?
I just wanted to mention to anyone that hasn't done the lab exercise B yet, some of the fill in the blanks can get a little bit tricky. It's not, always the exact answer that you think it is, and spelling counts and all that. So just a heads
If
up, it
it's
can get
really-
frustrating, but it doesn't matter how many times you do it. So, the one, I think I had to get it wrong 10 times, and then it showed me what it was asking for. It was like the the quadrants were kind of weird.
Elizabeth, if it shows you that and it makes it all weird and doesn't just allow you to put in, if it gives you partial credit for it, just go forward. Because
Yeah, I just
realize
wanted to make sure I got all the points.
what? Say it again.
So you don't get all the points until you get them all correct.
But you know what?
So,
I
you can
round
go
it up. I round it
Oh, okay.
up. There's a lot of questions. And if you run into a weird one, just skip it. Don't make it really, really difficult, and don't stress about one question, because I think altogether there's about 100 questions. Don't worry about one question. Wiley is really good at their pictures. We're gonna, one thing that Wiley has that McGraw-Hill does not have a lot are pictures of real anatomy, like real pictures from real cadavers. That's probably the one thing that I really like about Wiley that I don't like about McGraw-Hill Connect, is they have real pictures. And therefore they're really great for lab and anatomy. They're not really great when they decide that right becomes left, when you're trying to put in the 9 abdominal pelvic quad areas. But they tend to be very good at other things. So if you run into one question, just skip it. I don't think I ask you a single question that's worth 1 whole point, and that you'll actually lose the whole point for missing one thing. Other questions?
Which way was it, Professor Gessel? I mean, on some of the directional stuff, I remember last week when we were looking at the abdominopelvic, I don't know if I'm saying it right, the quadrants.
Yes.
Feel like one of our books had them one way
I-
and one
I
had, you
changed
told us
it.
which way to go and I forgot. to
I
write it
did,
down.
and I think I put it in there. Give me 1 second to actually look,
Okay.
because I think I uploaded it, but when I tried to upload something for 122, it still uploaded it wrong. So let me look here. Yeah, I don't, it's even in the textbook, as Christina can look and see, in the written textbook, it's wrong also.
Okay.
I don't know
Yeah.
how they can confuse right and left and publish it that way. But if you look here, on the one that, the figure that's in the textbook that was in the original PowerPoint,
That's the correct one.
this is, yes, this is correct. On the one, the original PowerPoint, they had the left over here and the right over here.
Uh-huh.
And I will tell you, the easiest way to orient yourself is your heart is always on your left.
Okay.
Your liver is always predominantly on the right. Your stomach's always on the left.
The funny thing was, this was the one question on the lab exercise B that was the weird one, but it wasn't the left and the right. It was the lumbar region. They didn't call it lumbar. I think they called it lateral.
Left.
So if you went to like the page, I'm sorry, if you went to the page before, because there was like, it was like back to back, fill in the blanks or whatever. It, because I ran into the same thing. If you went like a page or two back, it actually shows you what they labeled it. And that's how I figured out how to like get past some of these tricky questions, because everywhere else it has it one way, but then on that particular like quiz or whatever, it had it, or smart, whatever, it had it a different way. So you might just have to do that sometimes as far as troubleshooting to find the answer.
Or just skip the question. Don't spend too much time troubleshooting at something like that. There's a reason we call those the lumbar regions. And the reason is because the vertebrae in that area are also called the lumbar vertebrae. We don't call them the lateral vertebrae. We call them the lumbar. And learning these quadrants, learning these anatomical terms here. In a couple weeks, when we start learning the bones, and then we learn the muscles, you're going to see these terms again. Because certain bones are named the same thing, certain muscles are named the same thing. Right, for example, right here, this area right here called that we would call the acromial area. Right on your shoulder blade, about right there, highest place on your shoulder blade is the acromial process. And it's really, it makes your life a lot easier if you remember those regional terms. Another one, for example, the patella region right here. The patella is the anatomical scientific word for your kneecap. It's called the patella. Your brachial artery runs right here. Your axillary artery runs right here. Your sternum is right here. Pectoralis major is a muscle that's right here. Pectoralis minor is underneath it. Learning these terms will help you because this is only the beginning of a lot of anatomical terminology. So the easier this becomes for you, the easier that will be. Other questions? So I want to start chapter 1. I'm sorry, cutting in and out. Samantha, was that you? Just put in the chat room, yes or no.
That was her, and she wrote the question actually.
All right, let me look
On
in
the
the chat. Can you show how to get into McGraw-Hill? Because my Zoom is cutting in and out and the screen is lagging. If you come in McGraw-Hill, can you know what? Samantha, can you share your screen? Just say yes or no. Type in yes or no. Wait and see if she'll respond. I don't know if she's even getting the message. I can see her, but I can't. Okay. Okay. That worked. Was she even able to do it? One second here. Or give me one moment. I've learned sometimes how to do things a little creatively, and sometimes if your phone internet is being weird, sometimes just listening through your phone. If you've got a laptop and a phone and you just listen through your phone, it works also. Let's see here. Is it working better? Okay. Can you share your screen, Samantha? Samantha, I'm waiting for you. Can you type yes or, okay. So go down, go into McGraw-Hill Connect. Okay. You see where it says syllabus up at the top? Click on the syllabus. Now go down and click on in content, click on chapter 1. Actually, scroll up, scroll up. Scroll up. Click on chapter 1, the major themes of anatomy and physiology. Now scroll down a little bit, just a little bit. And click on the Smart Book chapter 1. And click on the Smart Book chapter 1 right there. Click on that. Now click on launch. So now click begin. So it's going to ask you to set up an account. It's going to ask you to confirm your email. And then give it a password. Now scroll down. Just click, click that, but don't give them a cell phone number. Continue. All right, review the errors. The passwords don't match. Now click continue. Let's see what happens. Click confirm. I would click save. Okay, so then you're in, there's the first Smart Book chapter 1, and then the chapter 1 quiz and so forth. Does that work, Samantha? Okay, Samantha, let's go forward at this point because we've got to get some of chapter 1 covered tonight. Okay, I'm gonna ask you to stop sharing, Samantha. Okay. Are there other questions or concerns? All right, let's get started on chapter 1. So major themes with me. And Samantha, something you might want to consider doing is consider calling the Hack IT Tech line. And before I keep going, I'm going to give you some phone numbers. So the Hack IT Tech line, bear with me here just for a second. I'll give you the McGraw-Hill line. And then the Wiley. Bear with me. Now I have to look them up, so give me 1 second. It doesn't take me long because I have them on my contacts list. The Hack IT Tech line is 717 780 2570. So that's a Hack IT Tech. The McGraw, spelled with 1 R, is 1-800 338 3987. And the Wiley line is 1-877 725 7503. Do me a favor, write down all of those numbers. Maybe if you're keeping a notebook for this class or a folder, write those numbers down on the folder or on a piece of paper so you always have them. Everybody have them written down? some major themes of anatomy and physiology. This. So anatomy, one of the major points of health sciences is anatomy, which is the study of the structures and the relationships among those structures. One of the first studies in anatomy were done using dissection. If I have a preference, a lot of times I still like dissection because it's a very hands-on thing. When they first started doing dissection, it was actually considered taboo. People who did it in secret and could be imprisoned for doing it. I'm trying to think who it was. I think it was Leonardo da Vinci. I think is who we call the father of anatomy. And if you've ever seen, if you look up the Body World exhibit, a lot of the person that they give credence to for what we know about anatomy came from him. However, his drawings were not discovered until after he had died because it was technically illegal to do them. Because to open the body and look at the different structures was illegal. Our most recent studies use imaging techniques. And as technology gets better and as science gets better, we get better and clearer and more definitive imaging techniques. Physiology is the study of how the structures function. A major part of understanding anatomy, physiology, and biology in general is understanding that the function of an object relies on its structure. If you change the structure, you change the function. If something happens, like a genetic mutation to the DNA code that is the blueprint for something's structure, and that mutation in the genetic code or change in the genetic code changes the structure, the function may or may not work. It may continue to work or it may not work at all because you've changed the structure. So function is everything, and it relies on the structure. If you change a structure, you're going to change the function. A good example of this is when we look at the muscle around the heart. Muscle works to contract, and the result is that the length contracts. The length becomes smaller. If you look at the heart has a looping length of muscle. Got one whole piece of muscle that loops from what we call the base of the heart. It's reversed, so the base usually is what we call the bottom, not in the case of the heart. We call the top the base. And this big, long strand sheet of muscle loops around the atria of the heart and then around the ventricles of the heart. Well, if the length of the muscle shortens as the muscle contracts, what's going to happen to the overall size of the heart as that muscle contracts? If this piece of muscle that's a continuous length shortens because that muscle contracts, what's going to happen to the overall size and shape of the heart?
It'll get smaller.
It's going to get smaller. That's right, David. It's going to get smaller. Why would we want the heart to get smaller?
Would it be to pump out blood?
To pump out the blood. Because if you make the volume of the heart smaller, whatever blood is in there, the pressure is going to go up and that blood is going to flow out. We don't talk about it so much here. We'll talk a lot more about it next semester. Only do a little bit. Everything moves from a high to a low, unless you physically force it to do something else. So if we move things from a high to a low, when we make the volume of the heart smaller, the pressure goes up, making the blood inside the heart under a lot more pressure. And because it's going to move from a high pressure to a low pressure, it's going to move out. What happens if for some reason, let's say part of the muscle, like right here, quits functioning? Let's say this part of the muscle quits functioning, or this part of the muscle quits functioning.
You wouldn't be getting adequate blood supply to the rest of your body?
Why not?
Because there's not enough pressure to constrict the heart muscle to push that blood out.
Right.
From
if we make it so that this is no longer, if we damage it right here so that this is now one length that ends right here and one length that ends right here, can you see how it's not gonna, when it constricts, it's not gonna function as efficiently? That's why myocardial infarctions are not great things. A myocardial infarction meaning death of part of the heart muscle. One especially right here is probably going to be almost always lethal. And we won't talk about it this semester, but almost the beginning of next semester, you'll learn that the major artery that runs right here, when it kills some of the heart muscle because it gets blocked, if the blood in that artery gets blocked, it will kill that heart muscle. And when that heart muscle dies, the heart no longer can pump this area. And that's when someone dies from a heart attack.
What did you call that myocard? What did you?
Yep, let me put it. And I'll explain why I'm calling it what I'm calling it. A myocardial infarction. Bear with me, I'm writing it in here. Myocardial infarction. I'm not sure where the infarction part comes from. I'd have to look that up. But myo means muscle. Cardio means heart. I'm guessing that infarction means a disruption.
Hi, Professor.
Yes?
I'm an EKG tech slash monitor tech. So like I catch heart attacks all the time. It depends on what's going on with the patient when it comes to heart attacks. Sometimes it can, and what's going on with like the heart. Sometimes the heart attacks can originate in the lower region, and that's the ventricles or the atria.
Right. And it depends on which artery gets blocked and where. You're right. Usually, however, if in this area right here, and I'm going into more depth here than I wanted to, and was my own fault. But this area right here if when you look at a heart, this is the left ventricle. The major part of this area right here is your left ventricle.
Your picture's gone. Your picture's gone.
Oh, shoot. Thank you. This whole area right here is the left ventricle. The left ventricle, it really is probably one of the most important parts of your heart because it's what actually pumps the blood out to the rest of the body. And the reason I said that this artery that runs down like this, that a clot in that one is almost always fatal. They call it the widowmaker, and it stands for anterior interventricular artery. If you want to go online and say, why are clots in the anterior interventricular artery most likely to cause a fatal heart attack? And it will tell you that this artery here feeds the majority of the left ventricle. And so if you get a clot in that, you're going to kill the muscle of the left ventricle, depending on where that clot is, because it's a pretty long artery that runs down the front of the heart.
Because it feeds such a large portion of the heart muscle.
But it's specifically the left ventricle too, right?
No, but a large part of that ventricle, that's the main pumping portion.
As my mom says, who's my retired nurse practitioner in the background, it's because it feeds such a major part of the heart muscle, most of the left ventricle. And I'm going to stop going off on that tangent because we could talk about that for a long time, and you just have to wait until Biol 122 because you'll see a lot more there too. So development of techniques to look at the body without having to perform dissections has greatly accelerated the progress of health sciences. One of the oldest techniques, isn't the oldest, but one of the oldest techniques was radiography or x-rays. X-rays are great for looking at dense tissue because they're easily absorbed by dense tissue and they move right through less dense tissue. So everything where the x-rays are absorbed comes out looking white. Where the x-rays are not absorbed, it's black. So they're really great at looking at harder tissue like your bones. A lot of some of your stronger connective tissues. So x-rays will pass through the soft tissues of the body onto the photographic film and produce dark images. And where the x-rays are easily absorbed, it appears white. This accounts for about 50% of all medical imaging. Another thing that we can do with x-rays is we can look at specific structures hollow vessels, hollow organs, by filling them with a contrast media, usually a heavy metal solution or a heavy dye. And then we subtract the background from it, the picture. So that the only thing that you're seeing is where the dye is. And the rest of it looks clear, looks blank. I think I've mentioned this before, so I'm hearing impaired. And I have recently gotten a hearing aid. You'll learn in the very last chapter that we cover, almost the last chapter. I'll talk more about my hearing impairment. But for right now, what I wanted to tell you is that I have the hearing technician that I was working with over the summer, and she was really great. But she explained to me that she had an aneurysm. And what an aneurysm is, it isn't what we think it is. Publicly, what we think it is not what it is. An aneurysm, bear with me here, I'm going to write it down. An aneurysm and aneurysm. I'm not sure if that's right. And A-U-R. That's right. An aneurysm is what we call a weakening of the blood vessel. Weakening of a blood vessel. So what it is it's essentially a bubbling out. If you've ever had blown up a balloon and you saw that part of the balloon was not as thick, the rubber wasn't as thick as the rest of the balloon. Have you seen this before when you've blown up a balloon, maybe an older balloon? And you know that it's just going to explode at that area at some point. That's what an aneurysm is in a blood vessel. It looks almost exactly like that too. Having seen them in cadavers, that's what it looks like. Oh, and we'll bring this will come up again when we talk about the brain, but a hemorrhage is a rupture of an aneurysm. Or when a blood vessel ruptures. R. And the reason I bring this up right here is we were talking about how they diagnosed it for her. And being the scientist that I am, you'll learn that I tend to be very direct and I don't really have an emotional filter a lot of times. And so I like when people tell me about these kind of things, I'm like, oh, that's so cool. Even though it's really not cool for them, but it's really cool for me. And so I was asking her, how did they diagnose this? And she was going to get me a picture of it. And she never got me a picture of it. But what it was an aneurysm of her internal carotid artery. What that means is that here, this is your common carotid artery right here. This is your external carotid artery. This one that's coming back this way is your internal carotid artery. And so what that means is that somewhere right in here, right around where her ear was, so a little further up here, it was showing a bubbling out of the vessel. And she was explaining to me what they thought the size of it was. This is how they do that. This is how they can diagnose aneurysms. So this is what we use, angiography. Angio means vessel, graphy means picture. So meaning to take a picture of the vessel by subtracting away the digital background. One thing I want you to get out of this semester, and I'm going to do it a lot, is learn that if you can break down words, you can understand their meaning, even if you've never heard that word before. Because I will go through a lot and we'll talk about breaking down a word and determining what that word means based on what are the different parts of the word. Physiology and anatomy and biology are great because you can do that. Sonography, actually, I think I was wrong before. X-rays are the oldest. Sonography is the second oldest and the most widely used method of imaging. Sonography or ultrasounds require a handheld device that's pressed against the skin that produces a high frequency sound. You've heard of bats and how they detect prey, that they put out these high frequency signals and it bounces back. That's how the ultrasound is working. It puts out a high frequency sound that bounces off certain surfaces within the body. And the refraction pattern of those sound waves, or the deflection pattern of those sound waves, allows you to generate a photo. So they echo back from internal organs, generating a picture of what the structure. It allows for the avoiding of harmful X-rays. We use it in obstetrics and allows you to view tissues in motion. You can't, X-rays you can't view in motion. It's hard. These are also softer tissues. You've seen my little teaching assistant up here who's snoring in my lap at this point. But I have 3 cats. One of my cats is a special needs cat. And he, about a year and a half ago, it's almost been 2 years in May. He almost died on me. And he is now, he'll be 15 in June. And so when he was almost 13, he almost died. And what happened is, because I told you I'm fairly direct. I'm also kind of aloof and I don't notice things until things are bad. I don't tend to notice details unless you point them out to me. And he went from being 9.5 pounds to being 6.5 pounds. And by the time I got him into the vet the next day, he was 6.25 pounds. And I got him into the vet, and the vet, looked at him, and, it was during the pandemic. So I was out in the parking lot in my car while they were looking at my cat in the veterinarian's office. And he said, your cat should have, from his frame alone, his skeletal frame alone, he should easily be 11 to 12 pounds. And mind you, I told you it was 6.25 at this point. At that point. And I said to, I said, you know, he's never been bigger than 9.5. He's never been bigger than 9.5. And I mean, I've had this cat my his whole entire lifetime. Got him when he was 6 weeks old. And he said, I want to do some blood work. He did some blood work, came back the next day. We talked on the phone, and he said his creatinine levels are really, really, really high. And creatinine, we'll talk about it later, but creatinine is a muscle product. And sometimes when you're working out extensively, you'll have some creatinine in your blood. You don't have really high levels of creatinine, because what that means is that your muscles are breaking down too much. And so he went on to tell me, you know, that he was going into catabolic muscle breakdown. He was just breaking down all his muscles. And I said, so what you're telling me is that even though my cat eats all the time right now, he's showing all the signs of being anorexic. And he said, yes. So essentially that's what I'm telling you. And so I took him that night. I took him up to Towson's Emergency Pet ER, and $2,000 later, we found out that using an ultrasound, we found that his intestinal tract, which is really soft tissue, was at least 2 times the thickness it should be. And as we'll learn about in chapter 3, that's a big deal because diffusion is important. When your small intestines increases in thickness, it means you're not absorbing your nutrients. So even though he was eating all the time, he wasn't absorbing anything. And so as he was eating all the time, he wasn't absorbing anything. And so he was breaking down his muscles for survival. And you'll see him eventually this semester. He's kind of my firecracker cat, because now he is 14 years old. Like I said, he turns 15 in June, and he's a very happy 14 pounds. And he looks great and he acts great. And he actually acts like a much younger cat now than he did 2 years ago. And my mom, she doesn't call him this anymore. She used to call him Chunky. She would tell me he was kind of fat. And I'm like, Mom, don't call him that. And I think it's hard for me to think about that, because I saw what he looked like when he almost died. And we were told that if we had let him go another day, he'd probably die. He probably would have died from it. But the reason I go into that story is they saw that with an ultrasound. If you think about your thickness of your small intestines, which is probably about, I don't know, a millimeter, probably less than a millimeter, is probably about a 1/2 of a millimeter. What that's saying is that his intestines is about 2 millimeters. Or 3 millimeters. And they measured that using an ultrasound. And now he's on a diet. He looks great. He's on a special food, and he looks phenomenal. And it's a food that's more easily absorbable. And he has just started putting on he put on a lot of weight. And once he got to 14 pounds, he's just stayed there. And it's a happy medium, and I'm okay with it. If he's going to be a little chunky, I'm good with this. But all right, coming off that tangent, coming back to this, CT scanning, computed tomography, is useful for detecting things like tumors, aneurysms, cerebral hemorrhages, and kidney stones. If you look here, tumors tend to be harder tissue. Cerebral hemorrhages are what I told you what a hemorrhage was. When the annual, are you going to bring him over here, Mom? Okay, my mom's bringing the cat over. He loves being on show and tell. He hates it, but come here, mister.
We need a visual aid.
Come here, Monty. Come here. This is Leo.
Oh, pretty.
Yeah, say I'm a wild child too. Oh, you're a
Oh,
wild child.
wow. You probably couldn't tell his weight because of all that hair.
Well, I was living with my friend and his significant other, and they told me when he was about 9.5, they kept telling me he was fat. And I was really, I haven't brought it up with them because I think it would break their heart. I know, now you're stuck in my clothes. And the thing is, he gets mad when he gets stuck. He's my firecracker.
But still, I know it's my fault. Yep, there.
You hear him whining and growling?
I have a kitty cat, actually mine's right here, who's almost 16. And
Oh,
she
wow.
gets so mad when her claws get caught in my clothes too. She'll start hissing because she's like,
It's your fault. It's your fault.
pretty much.
Somehow she got stuck and now it's all your fault.
Anyway, she's my school buddy. She'll sit on the bed while I do all my schoolwork and during lecture. But she gets mad because sometimes if I'm using the computer in my lap, she's like, "Oh, I can't sit in your lap."
It doesn't work so well. Yes. It's quite entertaining. He was the first indoor cat I've ever had, and it's a whole new adventure. So CT scanning, it is very similar to an X-ray. If you think here, cerebral hemorrhages, meaning that the blood, this is looking at cerebral arteries that have broken, that have ruptured. The reason I say that aneurysms, cerebral hemorrhages, remember how I told you aneurysms could be detected with this? This is also uses some X-ray to take that picture. The reason I'm making this all complicated is because computed tomography is essentially a spinning X-ray tube. If you think about an X-ray, you lay down or they put a piece of part of your body and they tell you lay it flat and they take a picture of it, right? An X-ray, or excuse me, a CT scan is essentially when you lay still and the X-ray tube spins around you. For little kids, they tend to put them under for this kind of thing because I've never had a CT scan, but I can imagine it would be a little unnerving and a little loud, and they want you to stay very still.
My coworkers call the CT and the MRI the spicy donuts.
Slice you into donuts, I can imagine.
Spicy donuts.
Say slicey donuts?
Spicy. SPICEY. They call it the spicy donut.
Slicey donuts.
Slicey, yeah, slicey in the donut.
Because it slices.
No, we call it spicy donuts. Like
That's
spicy,
what I
like
thought
the
she
food.
said. Okay, spicy donuts. Why do they call it spicy?
Because it makes everyone agitated when they have to go in, and a lot of times they go in because there's something wrong. So it really makes patients aggravated. So we call it that, and then also we see cool things.
If they weren't annoyed before, they get more annoyed. Okay.
Yeah, basically. I can't tell you how many times I've been cussed out when someone says, "Oh, I gotta go in the CT."
you know what, I've had an MRI, but I honestly don't remember a lot about it because it was right after an accident. I don't remember anything about it, but I do remember that they did one, I think, maybe. So it's a spinning, and like she said, a spicy donut. It takes really, really good slice type images in a 3D scan. She's coming this way, Mom. So low intensity X-rays with computer analysis can increase the sharpness of the image compared to an X-ray. This, for example, is an aneurysm. Possibly also, maybe I'm not completely right. I think it's an aneurysm. It could possibly be a tumor, but it looks more like an aneurysm. MRIs are better than CT scans for visualizing softer tissues. They are best because, and especially fluidy, tissues that are fluidy. She's right here, Mom. She's right here. They're best for visualizing softer tissues. They move right through harder tissues. Let me put it this way. Tissues that have a lot of water to them are easily visualized with an MRI. And the reason is because an MRI works to align the hydrogen atoms in a magnetic field. And we'll talk about water in the next chapter. Well, water has is 2 hydrogen ions for every 1 oxygen atom. And so tissues that have a lot of water are easily visualized with an MRI. What it does is it aligns those hydrogen atoms and then looks at the energy coming off the atoms to produce an image. So you won't see a bone because the bone isn't high water. It doesn't have a high water content in comparison to the brain. So it will pass through the skull bones and allow you to look directly at the brain. It'll allow you to go through the vertebral column, the bones of the vertebrae, and look directly at the cord. She okay, Mom? She's just being stubborn. A PET scan or positron emission tomography scan can assess the metabolic state of a tissue. What it does is it looks for tissues that have high metabolic rates. So rather than looking specifically at the solution or structure itself, it's saying, what's the metabolic activity of this structure? Positron emission is radiation. So positron emission is a form of radiation. What they do is you insert or inject a radioactively labeled metabolite like glucose. And you look for the areas of the body that are breaking down that glucose the fastest. And they come up as looking red in the images. So you're looking for the gamma rays that are coming off it's looking for the highest metabolizing tissues at any given time.
Quick question.
Go.
I've seen PET scans. I mean, usually when I see like a PET, like an example of a PET image, it's usually the brain. And I was just curious if you knew if they do that with other organs.
I think so. I think they use it for tumors.
Okay.
Let me bear with me just for a second here. They use it a lot for brains because they can use it for mental illness. They can use it for right here. This particular one is looking at a brain with Parkinson's disease versus a normal one. And we'll talk about this when we talk about the brain. But this area right here is what they call the substantia nigra, which in the brains with Parkinson's becomes severely diminished. So essentially it causes death of the organ. But I think they use it to look at a lot for tumors. Let's see here. PET scan. I'm going to do something first because I think they can do it. Rather than do invasive, let's go in and cut up your liver and see how many tumors you have in your liver, which would be a really bad idea unless you really have to, because your liver has so much blood running through it.
Professor Getzel, is this a like PowerPoint? It'll be available on
The PowerPoint is available to you.
Okay, so if we want to go back and look at some, like if we didn't have a chance to take all our notes, we can go back and.
Yeah. Yep. It's all there. So right here, here's your liver. These areas right here are liver metastases of a tumor. Looking at a PET scan. Because when you think of what a cancer is an actively growing set of tissues, meaning they're actively metabolizing. And they're growing in ways that the rest of the normal organ is not. Here's another one. I think we will see more of them later. I can't remember everything that we talk about, but I think we will see more of them later. But that was a really good question, yes.
Thank you.
You're welcome, of course. I like that you guys ask questions. I really like it. It's hard when I feel like I'm just talking to myself here. Of course, I went to the wrong class. So what structures do you think would be seen better by an MRI than an X-ray?
Brain.
Would be seen better by an MRI? Mm-hmm. What else?
Spinal cord,
The spinal
like
cord,
especially in the skull, you were saying where it's enclosed.
right? What structures are seen better by an X-ray than by a PET scan?
Bones, like
Bones.
hard, dense.
Right. So yeah, anywhere where the tissue is harder, dense tissue. Like we saw with David's question, positron emission tomography is looking at highly metabolizing tissue. Ellen is pregnant and tells Janet, one of her coworkers, that she's scheduled to get a fetal sonogram. Janet expresses alarm and warns Ellen about the danger of exposing a fetus to X-rays. Is Janet's concern warranted?
I would say in this case, no, because they don't use, like, X-ray is different from a sonogram. Sonogram doesn't have radiation.
Right. An sonogram or an ultrasound is using high frequency sound waves. They're not X-rays. So remember we talked about that complementarity stuff, that structure relates to function. The structure of any particular part of the body allows for the performance of certain functions. For example, the bones of the skull provide protection for the brain. The thin, really, really thin air sacs of the lungs permits movement of gases like oxygen and carbon dioxide. Told you about my cat and his small intestines. It's a really thin, thin surface area that things have to be absorbed through. If it becomes thicker, it doesn't work so well. What other examples of complementarity can you think of?
Would pores on your skin be an example of complementarity as far as allowing
what?
Just secretion of oils that can get trapped in the skin, or even like, I guess it's more so glands and things like that with sweating and maintaining body temperature.
It is. If you think, you can think even the water on the skin is by its structure alone allows cooling off. Your pores are actually, they come from a duct, a tubular duct that's going to secrete out onto the skin. Something that I will, we're going off on a lot of tangents tonight. Give me 1 second here for me. So I will highly recommend this book. If you really start to learn and recognize, once you get through the fact that anatomy and physiology is a complex course, if you get so you actually enjoy it, this is an awesome book. And I just got it. I actually I like audiobooks, so I listened to this book, and then between my mother and I, we listened to it 3 times. And it's by an author who describes the immune system from a layman's perspective. And one thing he does, he talks about pores in your skin, and he says that your skin is essentially a hellhole for bacteria. And that's exactly how he puts it. He says nothing survives on your skin. And so your pores are there for temperature regulation, but also as an immune function to protect you. Another thing about your skin is that it's got a strong keratinized layer to it. We'll talk about the integumentary system of the skin in a couple of weeks here in lab. It's got this highly hard, oily surface to it. Why do you think it's that way? What's the point of having a highly hard surface to your skin?
To make it hard to get into for
It's
pathogens
hard
and
to,
stuff.
yeah, it's hard to get into and it's hard to get out of. One thing that, you know, when people get burned, the major risk is dehydration, because that oily residue essentially keeps the water in. Okay, so sir, how are different ways of the body structure assessed for their function? First one is inspection, looking at a body's appearance, presence of a rash. Palpitation, gently touching a body surface with the hands, pulse rate. Heart rate determination. If you, I'll show you one thing really cool when we're talking about neat things about anatomy, is right here. And you only want to do it on yourself. Don't do it on someone else because you'll hurt them. But if you take your hand just like this, and here's my sternum about right here. Put your hand, take a finger and put it down fairly far. I mean, it almost hurts. That's why you're not going to do it on someone else, because it actually it hurts a little bit. Put your finger down there and then just stop talking for a minute. You got to put it down fairly far. Do you feel a pulse? You got to push it down fairly far. Do you feel the?
Yeah.
And it's fairly strong, right? It's not little. The reason you can feel a pulse right there is because your aorta, and I'm gonna come up because we had a picture of it right here. Your aorta is right there. You're probably about 1 to 2 centimeters above it. Somewhere where your fingers are, probably about right in this area right here. I've never done it on someone else, and I wouldn't do it because you don't want to hurt someone. So palpitation, gently touching body surfaces with hands. Auscultation or oscillation. Listening to body sounds to evaluate the functioning. Listening to the heart or lungs using a stethoscope. Percussion, tapping on the body surface with fingertips and listening for a resulting echo. Cadaver dissection. Cutting and separating human body tissues to reveal certain tissue relationships. And we'll tell you, I had a student about last year, who had me for biology 121 and 122. And her husband was a butcher. And she got me a bunch of organs. And this year I took a little bit more incentive and actually went to their shop and asked another butcher in their shop if I could get a bunch of organs. I have a part of a brain frozen up in the freezer at our neighbor's house. I don't have freezer space down here. And let me tell you, the fixed stuff versus the stuff that is right out of the body is very, very different. Because I have a fixed brain, and when we talk about the brain, I'll bring it out. I have some fixed sheep brain, and then I have this little bit of pig's brain that he essentially smashed the skull on a pig and got me part of the brain. And it's very different in its structure and function. It's the major reason why what I got from the butcher and what I get from a shop out of North Carolina, the major difference is that one of them has been fixed and one of them hasn't. I've realized more and more how much I like getting these organs from this butcher, because when you're looking at a cadaver or you're looking at a fixed organ, they don't act anything like a non-fixed organ. They do a little bit, but the non-fixed organ tells you how much you're missing. So cadaver dissection, cutting and separating body tissues to reveal tissue relationships. A comparative anatomy, studying multiple species to learn about the form and function and evolution. I like this particular diagram because the heart in an earthworm is essentially a spiral. And it's got 5 rings that contract. One thing that we went next semester, when you study a little bit about heart development, you'll learn that it loops up and down. It loops up and circles around to form the different compartments. So at some point during evolution, we got less of this spiral-like heart and more of a looping-like heart. I was looking at a fixed frog with my nieces and nephews over this last summer. I kept trying to find the trachea. And I could not find the trachea on this fixed frog. And my sister-in-law finally Googled it for me, and we found out that frogs don't have tracheas. And I was like, okay, well, that's why I can't find it. Based on the fact that they don't really have a neck. And so they don't really have a trachea. Exploratory surgery.
I'm sorry, is that the case with like sheep and goat and that kind of thing too?
I think sheep and goats have tracheas. I think they do, at least, you know, the pig one, I have a set of pig lungs upstairs. They have a trachea.
They do?
They have an esophagus.
Okay.
I think it's really the fact that frogs don't have much of a neck. Their head is essentially directly attached onto their shoulders.
Okay.
That's what she got from Googling it. I'm relaying what she saw on Google for why the fact that frogs don't have tracheas.
Okay.
So exploratory surgery, opening the body and taking a look inside to see what is wrong and what can be done about it. This, for example, seeing a blockage in the small intestines. Medical imaging, viewing, we talked a lot of what we already looked at, medical imaging, x-ray, sonography, CT scans, MRI scans, PET scans, digital subtraction, angiography scans. Viewing the body without needing surgery. Surgery is really invasive if you don't need it. Gross anatomy, being able to study structures that can be seen with the naked eye, such as the abdominal viscera. Histology, studying the tissue structure using a microscope. Histopathology, whenever you see pathology, pathology is looking at disease. So you're looking at your histopathology, meaning studying structure to look for signs of disease of tissue. This is a normal blood smear. This is leukemia. Cytology, the study of structure and the function of cells. So you could probably do this at home. There's a lot of things you can get online to do simple anatomy things. One thing would be to look at your tissue, your cells. Maybe you couldn't do it. I don't know. I have a $5 microscope that I have here at home that I got at a thrift store. It's a very, very basic microscope. But having seen what my nieces and nephews got for Christmas as a microscope, mine is better than theirs. Ultrastructure, viewing detail under an electron microscope. Looking at red blood cells versus white blood cells. Name the method that would be used for each of the following. Listening to a patient for a heart murmur.
Auscultation.
Right, auscultation. Studying the microscopic structure of the liver.
Histopathology.
You're close. What would it be if you're just looking at normal
Ultrastructure, right?
What?
Ultrastructure.
You could probably call it ultrastructure too. I thought histology, but you're right. It could also be ultrastructure. It depends on specifically what type of structure you're trying to look for. If you're looking at surface like this right here, this would be using an electron microscope, looking at surface area. I thought when I read that question, I think histology. But if I'm examining the liver tissue for signs of hepatitis, then I'm looking at histopathology. She's going to try. She can. You get by, Ruby? Okay. Learning the blood vessels of cadaver,
Gross anatomy.
gross anatomy, or cadaver dissection. Performing a breast self-examination,
Palpitation.
palpitation. As my mother says, palpitation. too. Palpation. Palpation.
Sorry.
Oh, you know what? She corrects me too. Welcome to my world. What time is it? You guys, let's take, I don't want to take the full 10 minutes. Let's take 5 minutes and just to get up and move around for a second. And so come back at 8:12. Right now it says 8:07 by my clock. Come back at 8:12. Do me a favor, you can turn off your camera, but don't leave because I need to take attendance.
I'm sorry. I thought that was you, not me.
She only corrected you because she thought it was me. All right, let's see here.
I'm missing dinner, but I'm like attending virtually. Like I'm attending on my phone. So like I have my computer screen up, but I'm making dinner. But I'm
You're
paying
fine.
attention to the lecture.
You're fine. I understand.
Okay.
Pacers, you want to come back here? Come here. Okay, I have one question. I have someone on here whose name is Zoom guest. Do you?
That might be me. That might be my phone number.
What is your name?
Lauren.
Lauren, I think you're already here. I thought you
I
were.
am here. I'm
No,
cooking
I'm
dinner.
sorry. You're already on my list. Are you Lauren Ashley?
Yeah.
You're already on my list. It's someone else.
Yep.
It might be me. I did send you a direct message just because I'm not sure why mine says Zoom.
It is you. What's your name?
Jennifer Cotto.
I got it. Okay.
Yeah, usually it logs in automatically as my name, and I don't know why tonight.
All right. I think I have everyone else here. Okay. All right, let's come back to this and we'll work through as much as we can until 8:40. So we talked about how structures related to function, functions related to structure. Structures become more complex in a hierarchy with more structures emerging. And if we say that more structures are emerging, we're saying more functions are emerging too. Because remember how they're highly related. One relies on the other. Starting at the very bottom, atoms come together to form molecules. Molecules come together to form macromolecules. Macromolecules start to interact and interrelate to form organs. Organs start to interact and interrelate to form cells. Cells interact and interrelate to form tissues. There's 4 basic tissue types that come together to form organs. Organs interrelate and interact to form organ systems. And I think there's 11 organ systems altogether that come together to form an organism. So it's a hierarchy that as things continue to interact and function together, you get new properties and new functions. One thing about anatomy and physiology is it isn't a sum of all the parts. The interactions between the different parts and the different structures means that the number of functions is well beyond the sum of all the parts. Your interrelationships among organ systems. Digestive system brings in food that gets absorbed into the blood. the blood then is circulated through the liver into the heart, and then that blood is taken to the lungs, where oxygen is picked up and carbon dioxide is released. That blood is then circulated, and some of it goes to the kidneys where waste is filtered out. We will talk about later that the kidneys also are involved in making sure that this volume is correct, and either bringing up the volume or decreasing the volume based on what's sensed. Throughout the body, as this blood is circulating, the nutrients or waste are being taken up or were put into the blood. So wastes are being removed from the tissues, nutrients are being absorbed. Well, a good example of this is this the production of vitamin D. What, does anyone know what vitamin D is? Why do we care about vitamin D?
Does it help with bone density and strength?
It helps with bone density because it helps calcium absorption, and we'll talk about that later.
I mean, vitamin D also, the amount, you know, or I guess your level in your body also can do with your like mood and whatever. So if you have a lower amount in your body, you're more likely, you know, to have depressive type symptoms.
Really?
So,
I didn't
and a
know
lot
that.
more people are deficient in vitamin D than realize it. Especially those of us like where we live compared to like, you know, closer to the equator where they're, you know, getting more of the sun all the time. So that's why a lot of people can, you know, it can definitely have an effect when you get the, you know, winter blues, you know, check your vitamin D levels, and it, you know, if you work on increasing them up, it could definitely make a positive impact. Anyway.
Okay, I didn't know that. You have a, let's see here, three organ systems involved in vitamin D synthesis. It starts in your skin. It's then transferred to your liver and then transferred to your kidneys. And along the way, different changes are made to the vitamin structure so that ultimately it's vitamin D, which can be used for the bones. Which one of these is a correct representation of the hierarchy of biological complexity from least to most complex?
C.
C is in Caroline?
Yes.
So, okay, that's right. Atoms and molecules are part of which level of organization? This is one that you probably are not really familiar with unless you've had some chemistry.
A.
It's A. We'll talk about that again in the next chapter, but most common with the chemicals organization. Chemicals become cells through their interactions. Cells become tissues. Tissues become organs. Organs together become organ systems. A structure that's made up of two or more types of tissues that performs a specific set of functions is at what level of organization?
The organ?
It's an organ. That's right. One way that we often work to diagram the hierarchy of complexity is using what's called a concept map. Right here are the different organ systems. And the different arrows show how they can interact with one another. So digestive breaks down food to be absorbed into the small intestines, digestive system. I would say, no, I'm wrong, circulatory system. The circulatory system, or the blood, includes the heart and the blood, or blood vessels. Circulatory system functions in blood transport. Let's go with one of these up here. Integumentary system functions to protect tissues and resistance of abrasion or dehydration, functions to prevent dehydration. Integumentary system includes skin and sweat glands. This, which includes bones and support, is the skeletal system. The reproductive system includes ovaries and testes, ovaries in females, testes in males. Anatomical variation is because no two humans are exactly alike. Anatomy books like to show you the most common organization of structures. However, some individuals lack certain muscles. Some individuals have an atypical number of vertebrae. Altogether, you have 33 vertebrae. 31 vertebrae. Not everybody has 31. Some people may have 32 or 33 or 30. Some people have an atypical number of certain organs, for example, kidneys. And some people show what's called cystus inversus, which means that you have a right-left reversal of organs. Your heart is on your right rather than being on your left. I had a friend several years ago who had a little girl born without any asymmetry of her organs. And so her heart was actually in the middle of her chest. She did not have a spleen. She was not born with a spleen because that's an organ that's specifically on your left side of your left side of your body. Her liver was in the center. They were very concerned when she was born that they were going to run into some major issues because the two different parts of your heart especially are very important for their functions. But somehow she came out doing great. And she, her plumbing, her vessels and the way their pattern is very weird and very bizarre. your aorta does this and it kind of comes over to the left and loops over. Well, she doesn't have that because she doesn't have the asymmetry. And so her aorta is not coming off to the left, it's coming down the center. But somehow for her it works and she's been fine. But when they saw that in the ultrasounds when she was very weird.
That
Go ahead.
so
Samantha, say it again.
about why wouldn't you give like penicillin or amoxicillin to have that?
Can you know what, can you type it in the chat?
In the book, it's
You cut in and out really badly. Write it in the, tell me in the chat. So normal kidney position is that your kidney, your right kidney is a little lower than your left kidney because your liver sits right here. However, some people are born with a pelvic kidney. Okay, why would, in the book it stated why would you not give amoxicillin or aspirin to someone with this condition? The condition, is it cystis inversus? I don't know. The aspirin would be most likely because it's a blood thinner. The amoxicillin is most likely because it's a widespread systemic antibiotic. Therefore, it would kill a lot of bacteria. Is it only to a certain age? Mom? If someone has cystis inversus, why would you not give them aspirin? Meaning that their right-left asymmetry is the opposite of normal. She says she doesn't know either.
Maybe, is it because they're going out of order? Like it's not processing through the liver in the same order that it would be, and that could throw things off?
I don't know, because usually your body will find a way to make things work. You wouldn't give aspirin. I can understand probably the aspirin depending on when you're missing an organ.
Depends on what the issue is.
Yeah, it depends on what the issue is. Let me look into it a little bit, because I don't know.
I hear that people who have that disorder, they're more likely to have bleeding disorders too. So that's why they're hesitant to give aspirin or any type of medicines like that.
Well, and if they have bleeding disorders, that's why they would not give them aspirin. Because aspirin makes it harder for your blood to clot.
The
Deactivate your clotting factors. Your platelets, maybe, as my mother's telling me in the background here. The amoxicillin, I don't know, because if it's amoxicillin, it's probably a lot of different antibiotics.
That's penicillin based.
Yeah. So yeah, amoxicillin is a penicillin-based derivative. And we have a lot of penicillin antibiotics. Yeah.
Oh, yes.
Yes.
Sorry.
You're okay.
I shouldn't be listening with half the brain.
So another thing is with the aorta, normally you have 3 main branches coming off. Well, what if you only have 2 main branches coming off and one of these 3 main branches is coming off only 2 main branches? Or instead of having 3, you have 4 branches. Basic functions that distinguish all living organisms from non-living organisms have an organization, that hierarchy of complexity, the interaction of different systems that are organized so that they interact in a certain way. Cellular composition. All living life comes from pre-existing cells that came from pre-existing cells. You think of an embryo, it starts as 1 cell, a fertilized zygote. Metabolism, you have to take in a certain amount of energy and break down a certain amount and eliminate waste. We're responsive. If you've ever grabbed the wrong end of a curling iron, you know that you're responsive, and it doesn't take much. Almost everyone who's ever curled their hair with a curling iron has grabbed the wrong end of the curling iron at some point. How long did it take for you to let it go? Not very long. We move. We have the ability, especially letting go of that curling iron, you can drop it. You can move bones to release something. Homeostasis is keeping things within narrow limits based on changes. So changes occur, and then we push things back into, we respond to things one way, grabbing if you held on to that curling iron after grab the wrong end of it, if you hold on to it for how too long, what happens?
You get burned.
You get burned, and you possibly, if you kept holding it, you would eventually just burn off your skin, right? That's a sense of homeostasis because it's a protective mechanism. You're being responsive, you're moving because you're letting it go. Your hand is moving to let go of it. Homeostasis is maintaining things within narrow limits for your survival. We'll talk more about this next time. Development, your cells differentiate and grow. You start from a single cell, and certain cells become they divide, and then they differentiate and start to specialize into different types of cells that have a specific function. You also reproduce in a like manner. And you evolve. I know some of you have children. You get together with a special person. You produce this child who genetically is different from both you or your spouse or your significant other. Genetically, they're different than either of you because there's an intermixing of genes. You evolve. Your children are never exactly genetically identical to you or your spouse. They're different individual all in themselves. Okay. Cells are able to transport substances from one region of the body to another, just as the body is able to transport substances to different locations, or skeletal muscles working with your skeleton can transport you from the sofa to the refrigerator. What basic life process is illustrated by this description?
A.
A? Why do you say it's A?
Movement.
What was that?
Movement in it, see?
I think it's C. It could, when we talk about metabolism, at the very basic nature, it is movement, if you think about it. Things get transported from one place to another. And you guys, let's end right here. It is 8:39 and it'll be 8:40 in just a matter of seconds. But let's end right here. Are there any questions? I didn't really pause, but you guys asked a lot of questions anyway, which is good. Are there any questions?
Those questions for the go along with the reading online, are they due tomorrow night at 11:59 as well?
The smart book assignment?
Yeah.
I don't think it is. I'm trying, if you go to. What?
It shows the 31st that they're due.
Yeah, they're not due until we finish the chapter. What I'll do is they're usually due a week after we finish the chapter in lecture. I put the game plan of the 31st. We will finish this chapter next Monday. And we will start chapter 2.
Okay, thank you.
You're welcome. Have a wonderful night.
Thank you so much. Good night.
Thank you. Good night.
Thank you.
Thank you. Good night.
Good night. Do any of you have questions for me?
I do have a question.
Okay.
I'm waiting on everyone to leave. I don't know if
Kira or Samantha, are you here? Samantha's the one who's struggling with the vocal.
I'm logging off now.
Okay. Samantha, are you here? You know, she's the one who's struggling.
Well, I have like 4 questions.
Go ahead and ask them.
I'm sorry.
Don't worry. No, don't worry.
So you said that PowerPoints are the best way to study for the quizzes, right?
Yes. Use that in addition to those worksheets.
Can I share my screen for a second?
Go ahead. Let me stop sharing. Wait 1 second. I'm sorry. Let me write this down. 30. Okay.
Okay.
Go ahead.
I'm not confused with this, for example. So, do we have to read the smart book in order to answer this labs
Nope.
exercises?
Nope. No, you don't.
So how I'm gonna answer them by
There, it's in the PowerPoint. It's also you can all there the PowerPoint. You can also watch these videos.
this PowerPoint?
Yes.
Okay. Now let
You
me.
can also there's a book. If you scroll down. If you go into not Wiley Lab exercises, scroll down a little further. Scroll all the way down, keep scrolling. If you Wiley Lab Manual, click on that. Now scroll up. Click on that. And now click on the e-textbook right there on to the very far left. Click on launch for the e-textbook. Scroll down. Right there. Click
Here?
launch.
I don't know if you noticed, but my internet kicked me out.
It kicked you out the class?
Yeah.
I think a lot of that times that depends on your internet connection. But I do post the recordings.
Okay.